In 2024, I took a stock BMW M44 and a BMW M42, combined them using production parts and off-the-shelf stuff to make a badass M44 42 I2B monster with Toyota 20 valve throttle bodies. In 2025, I intend to take it to the next level. We're going big with this sucker, and here's how. Alright guys, so as mentioned in the intro, this is the start of the new build for the M44/42 Frankenstein, and it's going to have more acronyms because I've combined components from different manufacturers to make this and to make what I think is going to be something really special. Now, considering what I've done here, I've still done it on a budget, believe it or not, and I haven't gone crazy. I will tell you what the last piece of the puzzle is if we decide to go down that route. I'm not sure how this is all going to pan out in terms of power to weight with the E36 chassis, but there's only one way to find out. So thank you everybody who watched that video, the M44 Frankenstein build from 2024. I really appreciate all the positive comments and the feedback. It was a great build. But ultimately it was limited with what it was. Now, that engine made around 200 horsepower at the coast. That is on the flywheel. That's about 156 kilowatts on the flywheel. At the coast here in Gauteng, it was very different. So I'm going to refer to coastal numbers for now. I'm not going to kind of try and convert it to numbers up here. What do I expect from this? Well, let me take you through what we are going to do and what I've done, and why did we go down that route, and where are we going to go. So firstly, to start off, if you remember from Kyle Army, the BMW M Fest last year in 2024, I raced there with the Frankenstein, and it ran bearings through not only the mine shaft but a few different corners.
Jeez, that thing flies. Okay, got a failure.
And that ultimately kick-started this project. The crank got damaged. Obviously it ran a bearing, so the crank got damaged and the conrod got damaged. So I thought, okay, well, I also noticed when I stripped the motor that the valves started touching the pistons. And the reason this happens is because the standard valve springs are not strong enough to cope with the RPM. And inherently, if you keep revving it up past 7,000 RPM, these engines were originally never designed to operate up top there. So you could go there once or twice here and there, but if you keep going there, what happens is the valve spring gets a bit soft, and at high RPM, high speed, the valve can't close fast enough for the piston that's coming up. Ultimately, so the cam lobe is already off the valve bucket or the hydraulic lifter, and then the valve is still coming up, the spring is pushing it up at a certain speed, but the piston essentially comes up just a bit quicker and starts to just touch the valve. Now obviously if it's super high RPM, you'd get a smash and then it's catastrophe, and luckily we did not have that. It ran bearings before it did that, because if it does that, it basically bends the valve in the combustion chamber, and then the piston just keeps smacking the valve and destroys the engine. So luckily we didn't have that, so I was able to retain the cylinder head and all the good work we did there, and as well as the block and a lot of the good stuff. So that is what led to one of the parts of the engine. The other one was the crank got damaged. So the M44 crank, now if you remember, that motor was M44 bottom end and M42 top end. So M42 cylinder head because of the valve buckets, M44 has the rockers, M42 you get away with a better camshaft, more aggressive, and you can go wilder on the cam basically without buying special fancy cams, which I don't even think that they make. I haven't even checked, to be honest. On the bottom end, the crank is limited stroke of I think 83 millimeters. So basically it is a 1900, and that limits your power output because nothing beats capacity. There's no replacement for displacement. And obviously you can argue, depends on the design of your engine. If you want to run super high RPM, you might not want a 2.7 liter because of the piston speeds, whatever, you know. So you need to design your engine according to your needs, torque versus power versus all these good things. Now the car that I'm racing, this E36 in the class I'm racing, I'm going to be up against 2.5 liters and 3 liters, pretty much stock 3 liters, but they still make a lot more torque, and out of the box they make probably more power than this is going to make. So I needed as much torque as I could get, and that's why we eventually went for an E46 320D crankshaft. So that is the M47 crank, and that is an 88 millimeter crank, and that's 5 mils extra on the stroke, which already gives it a massive bump in displacement. And these cranks are forged cranks. It's super hard. I know this because I spent probably the better part of 5-6 hours polishing this crank. Next up was a set of conrods. Now the standard conrods, I haven't really read anything about these conrods that is wrong with these. They seem to be pretty good up to probably 8,000 RPM. Based on the research I've done, if you're boosting it, obviously it's all completely different. We're not turboing this thing, we are running normally aspirated, so these conrods were going to be fine. However, one of them was damaged. So I took the opportunity to A, future-proof the engine, and B, try and save a bit of weight everywhere. So with that in mind, I went for a set of FCP Engineering conrods. Now, the beautiful thing about a fancy I-beam conrod is that they all exactly the same weight, and they come with ARP 2000 conrod bolts. Their dimensions, it's obviously a forged steel, and like I say, the dimensions are all exactly the same. It's not cast iron or cast steel, this is forged steel, and it is just much stronger. So this can handle up to 600 horsepower and I think 9,500 RPM. We're never going to go near that. So that is one of the upgrades I did on top of the M47 crank. Next up was a piston. Now I did a lot of research on what I'm going to do with the pistons. The pistons, I could have used the same pistons that I had. I was concerned a bit about those though, because with the rods and the crank we could turn this thing up to a higher RPM. So I started searching around. I looked at M50, M3, S52, sorry, S52, S50, S52 conrods and pistons. The problem with the piston was the gudgeon pin was smaller than the M42 gudgeon pin. So I looked and I looked and I looked, and I eventually got lucky. I got put onto one of the Honda guys, and they had a set of K24 Honda forged pistons. Now I was originally looking at the K24 standard piston, the cast piston that comes with the K24 because the gudgeon pin size looked correct and the compression height, that's the height between the top of the piston and the gudgeon pin, looked perfect. So in other words, we'd be able to get good compression. I found a set of pistons, couldn't find rings. Eventually I got put onto one of the Honda guys and he had a set of used Wyseco pistons. Now that was an opportunity I just could not miss. So I bought them and it was a massive investment. And I got them for an amazing price. So these pistons were obviously built for a K24. The combustion chamber on the piston was our biggest challenge. They just sat way too high. So my machinist and one of my good friends, Robert Cantwell, he spent a lot of his life machining these pistons to fit inside the cylinder head, and he's done an amazing job, and we had to go through many iterations of clearancing to get these things to clear inside the cylinder head, and eventually we did. But I mean, if you look at this thing, they're just so beautiful. So we are going to use these stunning Wyseco forged pistons, and they've been matched up with the conrods to fit inside the cylinder head, and that kind of gives us our bottom end. But what that did do is it presented a challenge, because the bore on these bad boys, well, the bore I think on the standard bore is 85. The standard bore is 85, and these are the machine pistons I used for the M44 M42 Frankenstein. These bad boys 86.5. We bored it out to 86.5 millimeter bore. Now the original K24s I was looking at were 87 mil bore, and that would have been great, but these Wyseco pistons were just, you know, it's a Wyseco forged piston, you cannot turn it down. So 86.5 bore. So now with the 88 mil stroke and 86.5 bore, that takes this out to a 2069 or something. It's almost a 2.1 liter, so it's close as damn it to a 2.1 liter now, which is fantastic because it gives us a lot more torque. It would have been great if it was a 2.4, but beggars can't be choosers. So let's do a weight comparison on these components. So we'll start with the conrod. So the stock conrod is 550 grams, right? The FCP Engineering conrod, 548 grams. Okay, so we saved 2 grams there. Not that big a difference. Let's look at the piston, right? So the piston, these heavily modified M50 pistons, 329 grams, 328 grams. And the Wyseco piston, 293 grams. So the biggest difference between the two is the pistons. So that means, well, not sure what that means, a small gain in weight, but that's about it. That ultimately presented the next challenge, which I didn't pick up right until the end, unfortunate. The next challenge is that a head gasket, the maximum size I could get locally in terms of the bore was only 85 millimeters, which is a problem because you cannot have a gasket sticking into the combustion chamber, basically with the bore slightly bigger than the gasket, especially on the fiber gaskets, because it will not work. The other challenge is that with the piston, we could not take any more off of this piston. This is as much as we could take because the sealing of the piston becomes really thin. So we limited on the piston in terms of machining. We could not machine any more off. And then with the head gasket, the stock thickness is about 1.7 compressed. So that gave us a compression ratio of 21:1, which was a problem. So it was around there, somewhere around there originally. And then we machined it more to get it down, but ultimately the compression was way too high. I think we finished on 17 after getting the piston to this state. But ultimately I still could not run the stock gasket because of the bore. So I've had to have a custom gasket made from a company in Cape Town, and unfortunately that takes time, and I picked it up very late, and So we are waiting for that gasket. So it is a 3 millimeter thick copper head gasket, and it has the correct bore for this engine. So that is what we're waiting on. That will take the compression to about 13.7 to 1 before it compresses. So the copper gaskets do compress somewhat. I don't know by how much, but obviously the more it compresses, the higher the compression will go up. So we're probably sitting on about 14 to 1 compression, which is fine. It's a good number. I'm happy with that. It could have been a bit higher, but yeah, unfortunately with that challenge, there's not much we can do. So that is what it is on the bottom end. So we have the BMW M47 diesel crank, that's a 88mm, the Waseco 86.5mm pistons. We have the FCP engineering conrods, and obviously the block has been bored out to take it to allow for the piston. So that takes it to almost a 2.1 liter. So what did we do to the head? Well, so like I said, the biggest limiting factor on a stock cylinder head is the valve springs, and I could see that the valves were just touching the pistons. I got very lucky with that. Okay, you don't see it on here, but got very lucky that there was no damage on the cylinder head and the pistons. So what I've done is, if you go back to the M42 build, I used the stock camshaft and we reground them to the most aggressive grind I could go with the stock cams and regrinds. And that took us to about a 280 degree cam with 10.8 lift. That was the maximum we could go. And the challenge you have with that is your shimming and your valve bucket. So basically the way you shim and you set up the valve buckets, that becomes your limiting factor on your maximum lift and duration. So we couldn't do much more on the cams. But what I did do is I got a set of Supertech valve springs with titanium retainers. Now these are rated to 9,000 RPM as well, and they rated to 11 mils lift, I think, 11 mils, 11.5 coil bind, something like that. So these were also pretty penny, and I waited a long time for these, as well as the conrods. But that does not limit us anymore on the valve train. And again, my good friend Robert from RC Motorsport, he helped me out with setting the valve heights and just going through the head. Now we've also done some more work on the valve seats, a lot of really trick work that the rally cars do, and other trick work on the head. That I can't show you because there's a lot of IP in that. I opened up the ports a bit more, cleaned them up. The finish was a bit rough. I asked for a rough finish, but I just cleaned it up a bit more. And that ultimately should just give us a better flowing head, especially for the increased capacity. Now with these valve springs, what I'm going to do is I am going to change the cam timing a bit, and I'm going to rev this out to 8,000 RPM. I'm not really going to take it past that because I'm not comfortable with the solid lifter conversion we've done here. I think 8 will be the maximum, so the limitable will be set at 8, and you know, it'll be able to live up there, but I won't really take it much more past there. The important thing is that the dual valve springs on the valve train will be able to cope with that, and we shouldn't have any issues there. So along with that, I'm going to run the Audi coil packs, the Bosch 440cc injectors, the Toyota 20 valve 43mm RTBs, and my phone is ringing. So that's pretty much the story. We've got the Toyota RTBs, the 320 diesel crank. The block has obviously been bored out to cope with it. We have a Waseco forged pistons. I didn't tell you, but we have a new pump, oil pump gears. We have Supertech valve springs, we have FCP engineering steel conrods. The head has been improved. We have the valve springs installed. I've opened the ports up a bit, just cleaned them up, and we've done some trick mods on the valve train and the ports. So all in all, we should be golden for a really strong engine and good reliability. So something else I didn't touch on was the sump, the actual mods on the sump. I did a whole episode on the sump. The sump is with Robert at the moment. It's busy getting modified, and with all the changes I spoke about, not all of them but some of them, and him and I have discussed a few things, and he's obviously been involved with very high-end race teams, so he knows quite a bit more about it than I do. And so between him and I, we've come up with a design, and he's busy implementing that design. So all in all, I'm super happy. Hopefully we're going to get started building this puppy in the next episode. So yes, that is the plan. Right now I've got to strip another 330 from the Silver Fox. That is also going to come up in another episode where we figure out what happened there. But anyway, thanks for watching. I'm super excited to get started with this build, and I'm going to bring you guys along, and hopefully we can make some serious jam from this puppy. The last piece of the puzzle, promised you I would tell you what it is. Now it sits in the head. Let me take you through that. The camshafts. The only area I'm really limited here is the camshaft. The next step for this puppy and the next piece of the puzzle would be a set of cams from a company called Cat Cams in, I forget where they're from, Belgium or I forget. Anyway, so they do everything up to a 300-degree cam. I might not go that wild, but if we do that final upgrade, I have to do the Supertech valves that go with it, and then the Cat Cam lifters, because the standard valves are just not long enough to allow to take up that clearance, and I don't think they'd be able to cope with that kind of RPM, because then we'd rev this thing out to 8,500, because it would make its power between 7.5 or 7 and 8.5. So that ultimately would be the last piece of the puzzle. That and an aluminium flywheel, because I'm still running a chrome moly flywheel. So perhaps those upgrades are still in the future, but I don't think so. Maybe that's mega money on top of all of this. Is it going to be worth it? Well, I don't really know. I'm not that sure, but for now, I'm really happy with what we have here. Anyway, thank you guys so much for watching. That is a super recipe. I can't wait to get it together, and I can't wait to get this puppy on the dyno singing at 8,000 RPM. We'll see you guys next time. Ciao. Bye.